All right, so this is just going to go through the topics, okay? And then I've got a practice for us to do today, which is like a quizzes. Tomorrow and Thursday in class, you'll get to work on, there's one pocket that has like, or a review that has like 40 questions. So you'll divide that between Wednesday and Thursday. You'll turn it in at the end of class Thursday. And then there's a second review for you to work on Friday. On Monday, we'll go over it. I have another review for you to do on Monday, and then Tuesday will be your test, okay? But this is the topic. So I just said, and I'll repeat it again, that your test is 18 questions. The first 4 you can use your calculator on. The rest not. The first 10 are multiple choice, and then 8 free response. Okay, there's like 3 with multiple parts. I think it's 3 or 4 with multiple parts. Which they're multiple choice. And really you only need it for 3, but I needed to put a 4th one on there because I don't want to waste another piece of paper. So you don't even need it for the 4th. Okay, so in section 1.1, we talked about change in tandem, and it doesn't look like a long list, but this had a big chunk of information. We talked about independent variables, right? Independent is the thing that you're plugging in, and dependent is what you're getting out of it. So if it says function whatever determines blank, then whatever it determines is your dependent variable, and whatever it is you're plugging in is your independent variable. If it's in notation like f of t, then the t is your independent because that's what you're plugging in, and the f would be your dependent. You are going to get one question that says identify the independent and the dependent from blank scenario. Okay, hopefully that one was easy. Then we got into all the parts of the graph. We got into increasing, decreasing, zeros, y-intercepts, concave up or concave down from a graph. You could also get asked it based on a chart. So if I gave you chart information, could you determine if the rate of change was increasing or decreasing, which would mean it's concave up or concave down. Your rates of change came next. This is a lot of different applications. So you can find the rate of change from an equation, from a graph, from a table, okay? And this is where we do f of the second minus f of the first over second minus first. So this is also y2 minus y1 over x2 minus x1 if it's linear, but that same concept even if it's not, okay? We're going to either take, if it's an equation, plug in the 2 values, do second minus first over the x of the second minus the x of the first. If it's a graph, you can, if you're just comparing, you can like draw the little lines and figure out which is the steepest, that kind of thing. If you're doing a graph and you actually have coordinate points, then you can use those coordinate points to find the rate of change. And if it was a table of values, you would isolate the 2 that I give you from the range because it will give you a specific range and it will ask you to find the rate of change. So be prepared to do any of that stuff. If your rate of change is increasing, then it's concave up. If your rate of change is decreasing, then it's concave down. So that could happen from a chart. And then what wasn't on your quiz from 1.1 and 1.2 that will be on your test is the rate of change at a given point. So remember, if it asks for it at a given point, we don't just plug that point in. We plug in the thing closest to it. Because you're doing this on multiple choice, there's only going to be one right answer there. So I'm not going to give you like, typically I could do 2.001 or I could do 1.999, right? But we're going to pick the 0.001. Otherwise your answer won't be there. So I would find f of 2.001 minus f of 2 over 2.001 minus 2. And I would have typed this equation into my y equals. So the better you are at that on the calculator, the more comfortable you are at that process, the quicker this question will go. You could also plug those values in and then have to subtract them. But it is way easier to use your y equals on your calculator. So obviously that question would be on the calculator portion. Okay, then came the rate of change, linear and quadratic. We narrowed these down to lines and quadratics. The average rate of change from a graph, if it's a line, you're counting the slope. If it's quadratic, you're picking 2 points. And it will tell you which 2 points so that everybody has the same answer. It will give you the range. And then it could ask you for your average rate of change from an equation. And if it's a line, it's again the slope. So whatever m is in your equation, you don't even have to do the work of plugging in. And if it's quadratic, you're going to pick 2 points again. So plug in 2 points. And then we got into first difference, second difference, right? So rate of change of rate of change. The rate of change of the rate of change for a linear will be 0. There will be no change, okay? This one, the first difference will equal each other. And the quadratic, the rate of change of the rate of change will be the same because this is the second difference. Yep.
So the rate of change of the average rate of change for a quadratic would be the same.
It'd be the same number but not 0. The rate of change of that would be 0. So like if I had y equals negative 2x plus 3, my average rate of change is my slope, right? So this would be negative 2. And then the rate of change of the average rate of change of a linear would be 0 because they would all be negative 2. So negative 2 minus a negative 2, negative 2 minus a negative 2, it's all going to give you 0. But if it's a quadratic, whatever this is, your average rate of change is going to be a value that you'll have to plug in. And then the rate of change of the average rate of change will all be the same, but it will still be a value. It won't be 0, but those would all be the same. So if I picked 2, I'd have to pick 3 points along the quadratic. I'd get 2 rate of change and then find the rate of change of that. That would end up, well, so I need 4 points. 4 to find 2 rate of changes to find the difference between them. And when in doubt, you just figure it out. Like you can memorize that the rate of change of a linear is 0, but you could also find the rate of change of the rate of change. It will be 0. So if you forget, just try it out. All right, then came 1-4, which was polynomial functions and rate of change. So these were the ones where they were your smooth and continuous graphs. All right, so from these graphs, so you could have something that's like your full-on polynomial, okay? From an equation, it could ask you the degree and the leading coefficient. So if I had 7x squared minus 10x to the third plus 14x to the fifth. To find my degree and leading coefficient, I go to the one with the highest exponent. It is not always going to be first. So in this case, the highest exponent is that 5. The leading coefficient would be 14, and the degree would be 5. From a graph, you need to be able to identify local and global. So local meaning relative, could be more than one. Global meaning absolute, okay, can only be one or none. Min and max. So on this graph that I just drew, here would be a local max. Here would be a local min. And there would be no global because the arrows go up in both directions, okay? But remember that your graph can also be restricted by a domain restriction. So if it did something like this, that even if I came back down, actually, let me draw it like this. This here is a local min, even though it goes further south on the right-hand side, okay? These would be local maxes. The absolute min would not exist because the arrow points down. The absolute max, this is just a little bit higher, but that absolute max would be that point. And it will say x equals or where it is. So the max is blank when x is blank, and it will be specific as to where it wants it.
Why is there no absolute max in the first graph?
Because this arrow keeps going. It doesn't stop.
And there's no absolute min?
Same reason this keeps going, doesn't stop.
So then in the second one we drew...
There's an absolute max, but there's not an absolute min.
Oh, because they both go down?
Correct.
So Oh, so, okay.
There's no arrow that points up.
Okay, and
Yep.
there's no absolute min, right?
Correct.
Okay.
Yep. Guaranteed extrema, remember that if it's an even power, there is guaranteed extrema. If it is a positive, then it's going to open up. So I'm actually go over here. Sorry. Positive x to the even power means both arrows point up. So there's going to be a minimum. And if it's a negative x to an even power, then both my arrows point down and there's going to be a guaranteed maximum. And it would happen in between each set of zeros. So if it goes up and down and up and down, I know that there's a local min or max in between those changes of direction. So if my graph goes from increasing to decreasing and it crosses the x-axis, then I know it's got a local max, which is what this is.
Could there be an absolute maximum and minimum in the same?
No,
Okay.
not if it's even. It's either going to point up or it's going to point down. It can't do both. And if it's odd, it points up and down. So odd does not have a guaranteed. That's the difference, right? Odd, unless we restrict domain, odd goes up and down in this direction or up and down in this direction, which means there is no guaranteed absolute.
All right.
Yep,
So there's no guaranteed extrema.
on odd.
There's only if it's even?
Correct. Yep. All right, and then your points of inflection are where your graph changes from concave up to concave down. So if my graph goes up and down, okay, and this is concave down and this is concave up, then I have 1 point of inflection. And the point of inflection I put in coordinate point form. So let's just say that's like, I don't even know, 2, 0. That would be my point of inflection, where it changes from concave up to concave down. Questions on 1-4? Okay, then came 1-5, which was your polynomial functions and compact zero. This is where your imaginary or non-real zeros came into play. Okay, first of all, the number of zeros is equal to the degree, but that could be imaginary and real. So if I had x to the, if I had x to the 10th, then there are 10 zeros, but they can be a combination of real and non-real, okay? Real roots, non-real roots come in pairs, which means there always has to be an even amount of non-real roots. If I had 2i, I know negative 2i is also a root. If I had 2 minus 3i, I know 2 plus 3i is also a root. I skip multiplicity, but multiplicity is the number of times an answer occurs. If it's even, it bounces or touches and turns around. And if it's odd, it crosses through. It's going to ask you on what intervals your graph is greater than or equal to 0. So hopefully now that we know our end behavior and we would understand our zeros and our multiplicity, that should make that easier. Okay. Kimberly, you with us? All right, degree of the polynomial from a table. So this is your first difference, second difference, third difference, and so on. I think I didn't have it go higher than that, but this would be linear, so the degree would be 1. This would be quadratic, so the degree is 2. This would be cubic, so the degree is 3. That's on the multiple choice part. So it doesn't say quadratic, linear, cubic. It says the degree is 1, 2, 3. Can't be determined. Okay. One, 5 had even and odd. So even from a graph is symmetric to the y-axis, something like a parabola or a absolute value. Those are even. And then origin would be odd. So something like the cubic function or the cube root function. God bless you. And then from an equation, we replace x with negative x. If it goes back to the original, then it's even. If all signs change, then it's odd. And then we finished with polynomial functions and end behavior in yesterday's section. So this will be in limit notation, okay? So if x is even, or the exponent on the x is even and it's positive, both my arrows point up. So I would say the limit as x approaches negative infinity and the limit as x approaches positive infinity, both of these equal infinity. If it's even and negative, they both point down. So the limit of my graph as x approaches positive infinity, the limit as it approaches negative infinity, they would both equal negative infinity. And then odd points in opposite directions. So odd and negative, the right side increases, the left side increases, the right side falls. So my limit as x approaches negative infinity, the limit as x approaches positive infinity, f of x, so negative infinity goes up, this would approach positive infinity. And if it's negative, the right-hand side goes down, it would go to negative, or to positive, to negative infinity. And then the last one is if it's odd and positive. They falls left, rises right. So the limit as x approaches negative infinity, as x approaches positive infinity, f of x would equal negative infinity, and f of x would equal positive infinity. So you could see these in two ways. One, here's your equation, give me the end behavior. The other, here's the end behavior, like in yesterday's AP classroom, which of these could the equation be? That kind of thing where you have to understand it backwards. Sure. Mm-hmm. Where? There. All right, this is the AP classroom from yesterday. So number one says the limit as x approaches negative infinity goes to positive infinity. So if it's negative, we're talking left, and it's going to positive infinity, it means it's starting up. And then the limit as it approaches positive infinity is also, it goes to negative infinity, which means this falls to the right. So when you go through there, that means it has to be odd, which means I rule these out. The leading coefficient would be negative is the one that produces that. So you could see a question like that on the test, okay? Some of them are going to be pretty straightforward. 2 says if the limit of your graph as x approaches negative infinity, so we're talking the left-hand side goes to negative infinity, this is pointing down on the left-hand side, okay? Then it gives you all your options. Make sure you focus just on the highest exponent. So I'm looking at x to the 4th, x to the 7th, x to the 5th, and x to the 4th here. If it's x to the 4th and minus, they both point down, so that could be it. If it's x to the 7th and a negative, that means it rises left and falls right. Can't happen. If it's a negative x to the 5th, it's the same, rises left, falls right. And if it's a positive x to the 4th, they both point up. So the only one that works is A. And then 3, your highest exponent is odd. It is a negative on the front, so it rises left and it falls right, which means the limit as x approaches positive infinity goes to negative infinity was the only one that works. These weren't bad, right? Did we get green yesterday? Good. Questions?